Welcome to Domain 3 of the CISA Exam Prep Series. And in this session, we're going to break down exactly how organizations acquire and develop information systems. We'll clarify the important difference between project governance, the strategic oversight and alignment, and project management, the hands-on execution across each phase of the project through to closing. We'll explore the key project management roles and responsibilities, showing how sponsors, steering committees, and project managers work together to ensure project success. And you'll learn the major development methodologies from waterfall to agile and the different types of application controls that ensure data integrity throughout its life cycle. And throughout, we'll highlight the auditor's involvement at every step, ensuring that controls, compliance, and project outcomes remain front and center. Let's dig in. Welcome back to the CISA Exam Prep Series, and here in Domain 3, Part A, we'll focus on information systems acquisition and development. And while you may know me for my exam prep content here on YouTube, in my 9 to 5, I'm a cybersecurity strategist and a VCSO for a regional bank where I'm exercising my cybersecurity knowledge every day, like that which you'll find here on the CISA exam. More importantly, last year I helped thousands achieve cybersecurity certifications, like the CISSP, CCSP, and the Security Plus exams, and I'm bringing that proven formula to you here with the CISA exam. As with all my exam prep courses, you'll find a PDF copy of this presentation available for you in the video description to leverage in your exam preparation as you require. You'll also find a clickable table of contents available in the video description, and it should appear automatically on your YouTube video timeline. And Domain 3, which is Information Systems Acquisition, Development, and Data Conversion, is only 12% by weight. I will say there's quite a lot of auditor's perspective that comes up in this domain. So in spite of its relatively low weight, I think you're going to find a lot of auditor-specific guidance here that's important for the exam. And we are now at the halfway point of this series. So across 5 domains, in 10 parts, we are now in 3A, so 5 of 10. So looking at Domain 3A, we have 4 parts here. Project governance and management, business case and feasibility analysis, system development methodologies, and control identification and design. So we'll just start at the beginning with project governance and management. So if you are relatively unfamiliar with project management process, methodology, and the lingo, we will work to change that over the course of this session. Let's start with a look at the 5 phases of project management. It begins with initiating. This is the first phase where the project is officially authorized to start. It involves defining the project's high-level objectives, securing the necessary approvals, and it's often documented in a project charter. In the planning phase, the project manager and the team develop a detailed roadmap. This will include defining the project scope, setting a budget, establishing a timeline, and identifying potential risks. Then we have the executing phase. This is the doing phase, just as it sounds, where the project team performs the work defined in the plan to create the project's deliverables. So along with the executing phase, there's controlling and monitoring. So this phase runs alongside the executing phase. It involves tracking the project's progress against the plan, managing changes to the scope or the schedule, both of which are commonplace in non-mission critical corporate projects for sure, and reporting on performance periodically. And it wraps with the closing phase. So in this final phase, all the project activities are formally finalized and completed. This will include final deliverables being approved by the client which may be someone internal to the organization quite often. Closing out contracts, documenting lessons learned, which will help to improve performance in future projects. So project management is a phase we hear every day. Project governance, less so. Let's talk about the difference between project governance and project management. So governance is the oversight framework for how project decisions are made, ensuring alignment with business strategy and risk appetite. It's really an oversight function. It's typically performed by a steering committee. And then there's project management. This is the discipline of executing the plan to achieve the project goals within the defined constraints. It's a management function performed by the project manager. The key distinction here is governance sets the direction and provides the oversight. Basically, are we doing the right projects? And management executes the plan efficiently, basically doing the projects right. And project portfolio management is the centralized management of all projects to prioritize and align them with strategic business objectives, making sure that we're doing the right projects. So there are 3 high-level project management structures you should be familiar with, and these essentially dictate the project manager's level of authority. So in a functional structure, the PM's authority is fairly low. Work is basically siloed with traditional departments, and the project manager coordinates across those functions. There's a project structured organization where the PM holds a lot of authority because the team reports directly to the project manager. The project is the primary unit of work. In corporate environments, I find that this one is fairly uncommon. Typically in a corporate environment, we will see stakeholders and department heads and so forth in that project meeting, and the project manager is there and certainly doesn't seem to be the highest ranking person in the room. There's a matrix type structure. In this model, the project manager has a mid-level range of authority. Their authority is shared between the project manager and the functional department head. This is a more complex structure due to that sharing of authority, but it's very common. That's what your average enterprise environment looks like in my experience. And in any case, the IT steering committee is the group responsible for prioritizing project requests and providing the overall governance. So let's talk about key project roles and responsibilities. So senior management. They demonstrate commitment and approve necessary resources, much as is the case with many initiatives in any company. The project steering committee provides overall direction. They ensure stakeholder representation, and it's ultimately responsible for deliverables, cost, and schedule. Next, we have the project sponsor. This is the person within the business who provides the budget, the funding. They champion the project, and they assume ownership of the outcome. User management assumes ownership of the resulting system, provides user representatives, and they approve system deliverables. For example, if we were installing or implementing a new help desk ticketing system, user management would be the team that's going to assume ownership of that system and use and manage it when the project is complete. So the project manager provides the day-to-day management. They monitor costs and schedule. They're responsible for mitigating project risk, that is, risk to the delivery of the project itself. Quality assurance independently reviews deliverables to confirm compliance with requirements, to make sure that not only are deliverables being completed and handed over, but they meet the requirements outlined in the charter. A few exam tips here. The CISA exam will test your ability to distinguish between these project roles quite possibly. So the sponsor funds the project, the steering committee governs the project manager manages that project day to day. The sponsor is responsible for risks to business benefits, so they are owning that final result. And the project manager is responsible for risks related to delivery of the project itself. So let's talk about the triple constraint, sometimes called the iron triangle, related to project management. So a successful project has to balance three things. The scope, that's the deliverables, what the project will deliver. The cost, which is the budget for the project. And time or duration, the schedule for completion. So we're always balancing scope, cost, and time. And quality is the central theme that is affected by all three of these constraints. If we go faster, quality is likely to be lower. If we reduce the budget, quality is likely to be lower. If we reduce the scope, we can go faster, but quality may be lower. If we increase the budget, quality may be higher, but time will also increase as well. So these all affect one another in various ways that you have to contend with throughout the project to make sure that you strike the right balance of quality and cost and delivery time. So we get a end result that is usable but of adequate quality and reasonable cost. So project management tools you'll want to be familiar with. There's the work breakdown structure. This really decomposes the project into smaller, manageable work packages. It's the foundation for cost and schedule planning. There's a Gantt chart. This is a bar chart that illustrates the project schedule. In case you've never seen a Gantt chart or you're not quite sure what a Gantt chart looks like, here's an example. So it's a bar chart with the bars moving horizontally. There will typically be a task named. Sometimes you'll see the name of the person assigned the tasks. You'll see on this one there's some color coding that shows us the red tasks are behind schedule, the dark blue are on track, the dark gray are complete, and the light blue need to be completed. And you will see some arrows that are typically indicative of the relationship or dependency between certain tasks. That one task, when completed, then leads to, as an input, in the next task that will be completed. So let's talk about the PERT or CPM. So this is a network diagram that identifies the critical path, an important phrase in the world of project management. So the critical path is the longest sequence of dependent tasks that determines the project's minimum duration. So let me show you a critical path in a Gantt chart visually here so you know what I'm talking about. So what you see here are a series of tasks where task A must be completed before task B can begin, and then D and E and F together, which must be complete before H kicks off. So what you're seeing here is essentially the longest chain of dependencies that is going to tell us what our completion date looks like. And as you might guess, if we have to delay completion of any of these tasks, if they take longer than expected, for example, it's going to push back the delivery date of all of the subsequent tasks and the project as a whole. But that determines the project's minimum duration. So any delay in the critical path delays the entire project. That's your takeaway. So cost estimation techniques. So there's analogous, which is quick, but it's the least accurate. It uses cost from a similar past project, so we can take a quick guess at what our probable cost will look like. There is parametric, which is more accurate. It uses statistical relationships, such as the cost per server, for example. And we can then use that to more accurately estimate total cost. There's bottom-up, which is the most accurate, but also the most time-consuming. It estimates every single work package and rolls them up. There is function point analysis, and you want to be familiar with this term. It's a technique to measure software size based on user functionality, the inputs, outputs, files, etc., not the lines of code. Project benefits realization. So this is the continuous process of ensuring the project's outcomes achieve the promised business value described in the business case. We're going to circle back to business case in a bit. The benefits realization is going to be measured by metrics like return on investment. So the benefits have to be measurable. A couple of exam tips for you here. So number one, you don't need to calculate the FPA on the exam. You do want to be familiar with what function point analysis is, though. Again, basically counting inputs, outputs, etc., rather than lines of code. You just need to know that it's a technique for estimating software size based on functionality from a user's perspective. Also, remember that project success is ultimately measured by benefits realization, not just by finishing on time and budget. If we finish on time and budget and the business doesn't realize any benefit, that's not a very successful project. So what is the auditor's primary objective in project management? Very important question for you to know the answer of before you walk into the exam. So first and foremost, it's to provide independent assurance that the project is being managed effectively, that the risks are controlled, that the system will meet business requirements. Key activities of the auditor will include reviewing the project charter, the business case, and the risk management process that's being leveraged to capture and quantify risks over the course of the project. The auditor will often attend steering committee meetings as an observer. You're not a doer, you're an observer in this process. You'll review deliverables at key milestones to ensure controls are being built in, and you will advise on any control deficiencies. So your independence as the auditor in examining the artifacts of this project is very important. Your independence ensures that you can provide assurance about the project without bias or undue influence. You don't manage or make decisions for the project. You provide assurance about the project, that it's being managed effectively, that the risks are being identified and controlled, that the system will meet the requirements of the business. Taking on project tasks as an auditor would impair your independence to audit the system later. So remember, the information systems auditor is an advisor, not a doer when it comes to a project. And that brings us to part 2 of Domain 3A, business case and feasibility analysis. So you need to know the function of both and why they matter to you as the auditor. And the business case really focuses on justifying the investment. The single most important document for project justification is the business case. It provides the rationale for the project based on the expected business benefits. So the purpose is that it links the project to strategic business objectives. It provides the basis for the investment decision, and it sets the baseline for measuring success via benefits realization. Remember, the realization of benefit is that key indicator of success. But remember the function and importance of the business case for the exam. And on that topic of justifying the investment, there are a couple of scenarios where we might want to reevaluate the business case. Now, with stage gates and kill points, this is possible. These are predefined points in a project where a business case is reevaluated. And if it's no longer valid, the project should be terminated. So for example, perhaps we do some research and testing as part of a plan to build an application. And we discover that as we're doing our research, looking at the business benefits, the market analysis, perhaps we discover the market is no longer favorable for this application at the price point we'd like to bring it in. So perhaps we pause or terminate the project. We'd also see a stage gate or a kill point on a minimum viable product. So we build that application to what we call MVP, where we can then show that to our customers, be those internal customers or maybe pay the bills customers that own one of our other products. And if the feedback is not positive enough, then perhaps we terminate the project and the product itself. And I've seen that in the software world more than one time, where an organization builds a new application, they get it to MVP, they show it to their customers, and they get the shoulder shrugging, nobody's really excited, so they press pause and kill the project, at least for the time being. So the other item mentioned in the syllabus here is the feasibility study. This is an analysis to determine if the project is viable before significant resources are committed. In that software scenario, a great idea that we begin with some research to make sure that what we believe is possible in terms of building an application, bringing it to market, and trading that software for money from customers is likely to be successful. So there are a few different types of feasibility. That study, though, is how we assess a project's viability from multiple perspectives. So there's technical feasibility. Is the technology available, and do we have the skills to use it? Or in the case of building software, the skills to develop it. Economic feasibility. Do the benefits outweigh the costs? So we can do a cost-benefit analysis to try to answer that question. Your key metrics here will include ROI, total cost of ownership, and then there's operational feasibility. Will the new system work within the organization's culture and existing processes? And I've seen this in new product or cloud service adoption, that we have to assess how a product functions to see if it will mesh well with the organization's existing processes, or if they're going to have to make major changes to a process to accommodate the way a piece of software or a service works. The schedule. Can the project be completed in an acceptable time frame? Remember, we're balancing there the cost and scope and time to get to that happy medium. So if getting to an acceptable level of quality takes too much time, then the project won't be feasible. So from an exam perspective, remember the auditor's role is to review the business case and the feasibility study to ensure the cost justifications are verifiable, that the justifications do make sense from a benefits realization perspective, that the chosen solution is reasonable, that the process was unbiased, that nobody had a horse in this race where they benefit from selecting a particular solution or steering the project in a specific direction. Again, remembering the auditor is an advisor, not a doer. That brings us to part 3 in Domain 3A, System Development Methodologies. And if you've taken other security exams like the CISM or the CISSP, you're going to see some concepts in here you recognize from those other exams. So let's start with a quick look at the System Development Lifecycle, or SDLC. This is a structured framework for developing and maintaining systems. There are two primary approaches you want to be familiar with. There's what we call the predictive approach, also called the waterfall approach. It assumes requirements are well understood and very stable. The progress flows sequentially through distinct phases. It's very formal and it's documentation heavy. There's not much that can change in terms of the scope in a project that's going down a predictive path. Then there's the adaptive approach, also called agile. This assumes requirements will change. The progress is iterative and incremental, using short cycles and rapid feedback loops. This is very common in the software world. let's go a bit further. So the waterfall model I mentioned, and you'll hear that predictive or adaptive terminology very seldom. You'll hear it in this exam. It comes up in the PMP exam. In the real world, we tend to be talking about agile or waterfall, generally speaking. But that predictive process, the waterfall model, it's sequential, where each phase has to be fully completed before the next begins. You would use the waterfall model on a project when requirements are non-negotiable, determined by safety regulations, medical standards, or where errors impact life and death. So I would expect to see the waterfall model used when we're building an airplane, we're building an airport. I actually, in my project management training, sat next to a project manager who was primarily using the waterfall model in projects building nuclear reactors. Those are the types of projects where waterfall comes into play. The weakness of waterfall, as you might imagine, is it's somewhat inflexible. It's very costly to make changes once a phase is complete because it's sequential. Then there's the V-shaped model. This is an extension of the waterfall model that emphasizes the relationship between each development phase and its corresponding testing phase. So to say that, user acceptance testing validates the requirements, while unit testing validates the detailed design. Let me show you a couple of visuals on waterfall and V-shape so you get a better sense. So waterfall, I mentioned, is a linear, sequential design process where progress flows steadily downward like a waterfall. Requirements, design, implementation, verification, maintenance. Waterfall phases vary depending on the implementation you work with. These are the 5 phases called out in the official CISA study material. You need to worry less about these phases and more about the nature of the project methodology as I described it to you, the development methodology here, that it is sequential, that each phase must complete, that it's upfront requirements, stable, documentation heavy. And then here's the V-shaped model, which highlights that testing is planned in parallel with development, essentially. That's the key takeaway there. I've not seen V-shaped pop up in the field in my experience. So let's talk about Agile and DevOps. Very common in the business world. Probably 2 of the most common methodologies you will encounter as an auditor. So Agile is a collaborative, iterative approach to software development that delivers value in small, adaptable increments called sprints. Scrum is a popular Agile framework that helps Agile teams work together and deliver complex products. So Agile and Scrum, very common in the business world. DevOps, this is a culture that combines software development and IT operations to shorten the development lifecycle through automation. So DevOps is what enables continuous integration and continuous delivery, where we will also see infrastructure as code. Very common in delivering cloud infrastructure and services and software in a cloud environment. DevSecOps is the evolution of DevOps that integrates security practices into the DevOps process from the very beginning. It's what we call shifting security left, because security isn't bolted on after a service is deployed or an application is delivered. It's considered from the very beginning. So when we get into DevOps and CI/CD, there's a lot of automation involved, and a key audit concern is ensuring that segregation of duties is maintained through all of that deployment automation. For example, the person developing the code shouldn't be the person who is then testing and approving the code and then approving that deployment into the production environment. There should be multiple roles there where we've separated those responsibilities. Before we get away from this part of the discussion, I want to show you what Agile looks like visually. So it operates in short iterations of activity called sprints. A sprint is typically 2 weeks long. In projects where you want tighter control, it might be 1 week. So you'll go through what we call sprint planning, where you plan your work for that 1 to 2 week cycle. You do your development, your testing. At the end of that sprint, there's typically a demonstration, what we call demo day. And at that point, we have some iteration of work complete, what we have demonstrated that we will then carry into the next sprint, where we will plan our work for that next sprint based on our goals and what work has already been completed, and we rinse and repeat. And so a very small project might only be one sprint long. A very long project might be dozens of sprints. So let's talk about a few other key development methods that might come up. There's prototyping, which is quickly building a working model to gather early user feedback. The key risk there is controls like security, audit trails, and backup and recovery can often be overlooked out of a desire to build quickly, and in that case, maybe too quickly. Rapid application development uses prototyping, small teams, and powerful tools to develop systems very quickly. Component-based development, this is assembling applications from pre-existing reusable software components rather than building from scratch. There's business process reengineering. This is a radical redesign of business processes to achieve dramatic improvements. The key risk here is that essential controls might be re-engineered right out of the process, leaving a control gap that you as the auditor need to spot. So the IS auditor needs to identify key existing controls and evaluate the impact of their removal. So let's talk about the phases of the traditional system development lifecycle. So the SDLC is a structured sequential approach to developing systems, and we'll talk through 6 phases here. Feasibility study, where we determine the strategic benefits, costs, the viability of a project, resulting in development of a business case. Requirements definitions. This defines what the system must do, the functional and quality requirements, and active user involvement is going to be important here. And then there's the design phase. This assumes we are building a solution, a system or software. This creates the detailed technical specifications, including architecture, databases, program specs based on the defined requirements. Then there's the development phase, phase 4, and that's assuming we're building again. This is the actual coding and testing of the system based on design specifications. And then the final testing and implementation, which would include final user acceptance testing, data migration over to the new system, user training, and then establishing the actual operation of the new system and handing the care and feeding, the management of that system, off to operations. Post-implementation review, so after the system is live, this is the formal process that assesses whether the system met its objectives and if the projected return on investment was accurate. That's what the SDLC looks like when we're developing a solution. Let's talk about what the SDLC looks like when we decide to buy software instead of build. So when an organization decides to purchase commercial off-the-shelf software, the SDLC is going to change in a couple of phases. In particular, the design phase, which is phase 3, and the development phase, phase 4, are going to be replaced with software selection and acquisition. So rather than designing, we are selecting based on our requirements. And rather than developing in phase 4, we are configuring the software that we purchase. So the acquisition process typically begins with what we call an RFP, a request for proposal, which is sent to vendors detailing our requirements so they can provide proposals to us that we can choose from. Key evaluation criteria will include viability of the vendor, the company itself, the support terms and capability, making sure that we're going to get reasonably priced, fast responding, and competent support, and source code escrow. So park source code escrow, and we'll talk about that one in a minute. So just to visualize the SDLC for you in the buy scenario where we buy commercial off-the-shelf software, I said phases 3 and 4 change. So that's where we saw software selection and acquisition, and then phase 4 is software configuration. So I mentioned source code escrow. So what this is a legal arrangement where the source code for that software is held by a trusted third party, and there's a reason for that. It will be released to the buyer of the software if that vendor should go out of business, allowing for continued maintenance. That would certainly be less than ideal, But as a customer of that vendor, if they go out of business, we'd like to at least have the ability to develop ongoing patches and performing whatever software maintenance might be necessary. So just a couple of quick exam tips here. The auditor's role in acquisition is to review the RFP, the request for proposal, to ensure security and control requirements are included, and to ensure the final contract is reviewed by legal counsel and it protects the organization. All right, that brings us to the fourth and final section, control identification and design. And we're talking about controls in the context of software here. The core principle is that controls need to be identified and designed at the earliest stages of the SDLC, back in requirements and design, because the cost to fix control weaknesses increases exponentially as we move through the SDLC. The later we get into the process, the more expensive fixing a control weakness we should have identified back in design will be. Application controls are going to be a particular area of focus. These are controls specific to a business application to ensure data integrity. They are categorized as input controls, processing controls, and output controls. These are the controls within the software itself. Control identification and design is perhaps the most crucial task for an auditor because a missed application control can cost millions to correct in a big project. How expensive depends on the situation, but your key takeaway is catching those control gaps earlier is better. So let's talk through the specific types of application controls. We'll start with input controls. These ensure that data that's entered is authorized, accurate, and complete. These are preventive controls. They are preventing problems. Their focus is on input validation and edits, meaning that it's validating the input to make sure that it is accurate, and then editing, meaning giving the user a chance to correct or modify that input if it doesn't pass validation. That could involve showing an error message or highlighting fields that need fixing and letting the user make the necessary adjustments. There are about a dozen input application controls that are cited in the official CISA exam preparation materials. You should be familiar. I'm going to distill them for you here in a way that I hope makes it easier to digest for the exam. So first we have check digit, where a numeric value is added to data to detect common data entry errors. So the last digit of a credit card number, making sure that we get the right valid card number in. A completeness check that ensures a required field is not left blank, like the user can't submit a form without entering their name. A limit check that ensures a numeric field does not exceed a maximum value. Perhaps we have a limit check that ensures a payroll check for a given week cannot exceed $4,000. A range check that ensures data is within a lower and upper bound. For example, the day of the month must be between 1 and 31. A reasonableness check that compares data to a predefined standard of reasonableness. For example, if we get an order of 500 units of a widget, this might be flagged if the normal orders for that widget are less than 20 in a given order. A validity check that compares data to a set of predefined acceptable values. For example, a gender field must be M, F, or N, male, female, or not specified. Duplicate check ensures a unique transaction is not entered twice. A vendor invoice number is checked to ensure it has not already been paid, for example. A sequence check. So these are control numbers checked to ensure they follow a sequential order. For example, invoices numbered 101, 102, and 104 would trigger a flag for the missing invoice number 103. Existence check. This is where data are checked to ensure they agree with valid predetermined criteria in a file or a table. For example, a valid transaction code must be entered in the transaction code field. Key verification. So the keying process is repeated by a separate individual to compare the original keystrokes to the repeated input. So a worker number is keyed twice by different people and compared to verify its accuracy. Table lookups. This is where input data are checked to ensure they comply with predetermined criteria maintained in a computerized table. So for example, a city code is entered and the system looks it up in a table to find the corresponding city name. A logical relationship check. So if a particular condition is true, then one or more additional conditions or data relationships may be required to be true also. For example, an employee's hire date is checked to ensure it is not earlier than their date of birth. So input controls are the system's first line of defense. They are preventive controls. Now let's talk about the other two types of application controls, processing controls and output controls. Processing controls ensure data remains complete and accurate during processing. For example, at the end of the month, we're doing our run-to-run totals, making sure that we're verifying totals between processing steps. We're maintaining transaction logs, file reconciliation to make sure that there's nothing happening here with our transactions that would impact the integrity of our data, that it is still complete and accurate. Key risks here would be, for example, direct back-end database updates. If I could go right to the SQL server and enter data directly, I can bypass all of those application controls, and that's going to be a problem. So this type of access has to be strictly controlled, logged, monitored, and reviewed by management. Then we have output controls, and these focus on the results. They make sure the results are accurate, they're complete, and they're only delivered to the authorized recipients. So here we'd be talking about reconciliation of output reports to the input processing totals to make sure the outputs are expected in light of what the inputs were, ensuring we have secure report distribution so it's only delivered to the authorized people, and proper record retention. So your key takeaways for 3A. We talked about governance first thing. Make sure you understand the roles of the sponsor versus steering committee versus the project manager. We detailed all of those. Remember, the business case is going to help us as the ultimate measure of success. That business case defines the benefits we expect to realize, and the benefits realization which are realizing the benefits in that business case, are the ultimate determinant of project success. And know the auditor's role. Remember, the auditor is an independent advisor, not a project participant. They are an advisor, not a doer. The best time to add value in the SDLC is early, because it gets more expensive the longer we wait when we make changes. And then we talked about development methodologies. Make sure you know the key differences between waterfall, or predictive as it's also called, and agile or adaptive, and when each is appropriate. I tried to give you some examples of where we see these used in the real world. Make sure that you're familiar with how these two very different methodologies work conceptually and where they are commonly applied. Remember how acquisition of commercial off-the-shelf software changes the SDLC phases. Remember, phases 3 and 4 in particular change. You've got reference tables so you can study those in the PDF that comes with the video after you're done watching here today. Make sure you master those application controls. You may well get questions on input, validation, and edits. And I would remember the different types, especially the check digits. I tried to lay out the application input controls in the order of likelihood I thought you'd see them. I tried to put the more common to the top, but there's about a dozen there and you should be familiar. And remember the difference between input, processing, and output application controls, the three types. My friends, that is what I have for you in Domain 3A. I hope you're getting value from the series. We're now officially at the halfway point. If you have any questions, drop them in the comments. Ping me on LinkedIn. Happy to help anywhere I can. I'll be back in 2 or 3 days with Domain 3 Part B. And until I see you again, take care and stay safe.